negative 1 is 3, and then this is 6 over 3, which is 2, and then move everything over. Quadratic formula. So by the quadratic formula, my solutions are not x equals, c equals negative b plus or minus the square root, all that junk, right? So for me, negative b is positive 2 plus or minus the square root of b squared, so it's negative 2 squared, which is 4, minus 4 times a, which is 3, times c, which is negative 2, the entire quantity divided by 2 times a. How many of you have the quadratic formula memorized? Yeah? By this time? Okay. Again, that's not something I would supply you with. The quadratic formula, I would expect that you would know that by now.
Isn't it on our chart?
Probably. Somewhere in there. So 2 plus or minus, what's underneath that radical when you do all that?
28.
It's 28?
Yeah, or 2 roots of 7.
So 28 here over 6. And then you could go further and clean up the radical a little bit, right? It's, what, 7 times 4? So you can pull out a 2. So you got 2 plus or minus 2 root 7 all over 6. And then each of these has a factor of 2 in it. So you could reduce everything by a factor of 2. This will turn into a 1, and a 3. So you get 1 plus or minus, I don't need to write 1 root 7. I can just write root 7 and then over 3. And that's 2 different answers, right? Do they both live in my interval? I need to see if they both work. So if I do what's 1 plus root 7 divided by 3, what's 1 minus root 7 divided by 3. Make sure these both live in there. If not, I need to chunk one of them. So let's see, the square root of 7, I don't know. The square root of 9 is 3. 4 over 3, it's bigger, that's big. I'm pretty sure that lives in my interval. Let's see, this is like 1 minus 2 negative. I think that lives there too. Yeah. So you check these on your calculator, turn them into decimals. They've got to live in here. That fair? Check yourself. So they both work. So C must equal that, comma, this, either one. But if one of them didn't live there and you forget to take it out, then it's partially incorrect. Yes? Maybe 9 out of 10 points instead of 10 out of 10? Yes?
Would you want us to go and simplify it?
You mean like have to go from here to here? No, you don't have to. But you do need to make sure that they live in there or not. Yeah. All right, we good? How about number 5? So 5 really kind of leads into the 6, which is the graphing. But all I want there is increasing, decreasing, local max, local min for number 5. So which one on number 5 would you like me to do? C? Let's take a vote. C? All right, I think that's overwhelming. E doesn't scare you a little bit? All right, so let's look at this. X to the 4/3 minus 4x to the 1/3. I couldn't believe in my Cal 2 class, boy, I hope no one in my Cal 2 class watches this video. Couldn't believe my Cal 2 class how many students had trouble differentiating that. I gave them something like that, and they had so much trouble with it, which was the very beginning of the problem. The problem was if you graph that curve, what we do in Cal 2 is, you graph this, and it looks like something, whatever, In Cal 2, what we do is we imagine that you start here, and let's say you stop somewhere. And if you can imagine this, taking this graph off the piece of paper and imagining it's a string, if you were to straighten the string out and measure the length of that, what would its length be? We call that the arc length. But the first step to solving that problem is you have to take the derivative of that. And it was just like, oh my gosh, you know. But
They can put it in their calculator?
I don't know. Or they put it in wrong or something. I don't know. They could not. The derivative was all messed up on that problem. So, all right, let's do this. All we want to know is where it's going up and down, local max, local min, right? So all I need are the critical numbers. So I need the derivative, first derivative only, and set it to 0 and figure out where it's undefined. So first derivative of this is power rule, right? It's the first rule we learned when we took derivatives. Minus 4/3 x to the negative 2/3. That's the derivative, right? Now I have to set that equal to 0, right? So that's not something very pretty to set equal to 0. You could do that. You could factor out 4/3. I'm willing to do that, but in every problem I've done that is like this, I've never done that in class. I've never factored the 4/3 out. So I think I'm going to stick with my way of doing it, only because if this was like 4/5 and that was like 7/3, you couldn't factor something out. So we may as well be able, you know, like do it in a way that would work if those didn't factor out. Yes, I'm going to write everything as a fraction first, okay? So I'm going to write this as 4/3, then I have x to the 1/3 on top. Notice I'm not converting it into a root either. I'm not making that a cube root. And then I have minus, let's see, what's on top of the other side? Just the 4, right? Over 3x to what power? Positive 2/3, right? I doubt any of you have ever noticed this, but this is one thing that irritates the shit out of myself. When I write fractions as exponents, sometimes I write them like this, and sometimes I write them like this. And I've never been consistent on it. I've always just, it's weird. It's always bothered me that I do that. Okay, common denominator, right? So what am I going to introduce? I have a 3 on both already. X 2/3 is all I'm missing. So I introduced that over here, x to the 2/3, x to the 2/3. And I should set my thing equal to 0, shouldn't I? Since that's what I was going to do? All right. Good things are about to happen when I put these two together, right? X to the 2/3 times x to the 1/3 is x to the 3/3, which is just x, right, to the first power. So I get 4x here. I'll have my common denominator underneath. Over here, I just have minus 4 over the same denominator that I would have over there. So 3x to the 2/3 equals 0.
Now we only have to set the numerator.
Now you only have to worry about the numerator. Fraction can only be 0 if the top is 0. So x is 1. Now I also have to look at what? Where it's undefined, okay? Don't miss that one because it is there. You do have a problem here, right? Where's the derivative undefined? Well, take a look at your derivative. There it is, all nice and cleaned up. You can see if x is 0, you're going to have division by 0, right? So x is 0. That's the only place that causes a problem, right? When that bottom is 0. So I have 2 critical numbers. So what if you only get one of them on the test and you do everything else correct? How many points should I give you out of 10 if you just accidentally missed that one? See, that's what I have to live with. I have to determine the severity of the mistake, right? That's a difficult thing for me to determine.
It's
And that's what makes a lot of us different as instructors, is how much you take off for a mistake like that, right? Yeah, one could argue that, look, you're completely jacked up because of that, right? The whole thing's off. Others could argue, but you just missed that one little thing. Everything else is perfect. You knew what you were doing. You just messed up. So I'm glad there's no like standard for it. I like that there's no standard. All right, what now? I kind of already gave you a hint. I put it all out there. Number line, right?
Same points.
Test points, right? We're going to test these points. We're going to test points over here and over here and over here. And let's pick some points. What do you want? -1, 1/2, 2. Where are these going? Derivative. Okay, so that's, again, one of those things you got to be real careful with on the test. The only time you ever plug things back into the derivative is when you're doing test points. The only time you plug them into the original function is when you're a closed interval method, right? Test points go into derivatives. Critical numbers go into original function. All right. I just erased the derivative, but it was 4x minus 4 over 3x to the 2/3, right? That was our derivative. So I'm going to plug in -1. So on the top, I only care about if this is positive or negative, right? On the top, let me see, -1. Be careful, it's not 0. It's what? I plug -1 in here. -8, right, on top. So 4 times -1 is -4, minus 4 is -8. And on the bottom, is it going to matter? No, because this is what? Cube root and then squared. So no matter what I put in here, squared is going to be positive? Unless I put 0 in, but that's why I don't plug 0 in, right? That's why I plug something other than 0 in. So I know I'm going to get a positive down there. So it's negative, so that tells me my function is going down. Now, 1/2. If I plug in 1/2 right here, 4 times 1/2 is 2, right? 4 times 2. I'm sorry, 4 times 1/2 is 2, and then minus 4 is negative on top. Negative on top, and on the bottom, positive again, right? It's not going to matter. So that's going down also. And then I plug in 2, and that's where I get the positive, right? What does it appear that I have here? I have a local minimum. Where's my local minimum? Local minimum at an x value of 1. Now, I asked you if you could please go figure out what that is for me, right? So what is f of 1? So plug that in. What's 1 to any power? Okay, 1 to any power. 1. This be -3. So written as a point, it's the point 1, -3. I should have a local minimum there. Do I have a local maximum? No local maximum. No local max. We're done. Oh, did I ask for increasing? Okay, I did ask for increasing. I'm sorry, I thought I only asked for local maximum. Yes, I want to know where it's going up and down. I'm glad you mentioned that because there's something we have to look at here. So where's the function going up? Where's the function going down? So where's it going up? 1 to infinity, right? And I said use parentheses on increasing, decreasing. Where is it going down? Negative infinity to 0. And then the union 0 to 1. Can I just do instead negative infinity to 1? Why not?
Undefined at 0.
What's undefined?
They have undefined and
The derivative is undefined.
What's the derivative is undefined?
The original.
The original function is not. Which means what? These are those little subtleties, right? The derivative being undefined here means that my tangent line is undefined, right? Which means I either have a corner, a cusp, or a vertical tangent that goes like this. Where your tangent line is, like this, and then it gets vertical, whoa, shit, and then it goes back, right? At that point right there, your derivative is undefined. This is what we have here. The reason why we know it's this is because look what's happening. It's down, down, right? It's undefined. If you had a corner, it would do what? Go up, down, wouldn't it? And then this too, it would go up, down. You would have a switch in your increase, decrease. But the key to it is that 0 is in the domain of the original function. Yeah? You sure? Sure, sure. Okay. So I can say negative infinity to what? 1. Now, technically, would it be wrong to go negative infinity to 0, then 0 to 1? It technically would not be wrong because you do not have to include the point 0 in there. You don't have to include it because it's impossible to talk about increasing and decreasing at a single point. So if you leave it out, it's not bad. But it would show me you don't understand what's going on if you do that. It just wouldn't be technically incorrect. All right? So we're clear, right? If 0 did not belong to the domain of the original function, then you would break it up in 2 pieces. All right, would you like another one of those, or you want to try one? You want to try one? Which one do y'all want to look at? I thought the last one looked the most interesting to me. All right, why don't you try that? I'll start working it out up here. We only have 20 minutes left. Well, I don't think we're going to get to any of the sketching. What I might do is for 6, I might just look at some of those derivatives. Because I think that's the part that most people have trouble with. I'm sorry, were you asking me something, or?
Oh, no.
Yeah, it did. Yes, but you wouldn't get a solution here because you would move the 1 to the other side. You get x squared as -1, and that would be a non-real answer. I'll put that over here so you can see it.
And like a problem with this, we would
Yes.
say that we had a local max. We would say there's no local max.
No local max, no local minimum. Yep. Where is it increasing? Where would this function be increasing? Everywhere, right? Yep. So you would say no max or min, local. And then you would say f is increasing on -infinity to infinity, and f is decreasing. How do you say nowhere? How do we say the set that doesn't have anything? Empty set? If this is everything, this is nothing, the empty set.
So is that like a 0 line vertically down?
Yes, it's a little tilted. It's a little tilted. And that is the mathematical technical symbol for the empty set. It is not the number 0, although in the military they do use that, so you can distinguish it from an O, the letter O. In mathematics, it is not the number 0. It's the set. Imagine it's a basket that's empty, as opposed to the number 0, which is a basket that has a number 0 in it. Okay, which means that basket would have something in it, right? It's one thing, it's the number 0. The empty set's an empty basket. Often, it's also called the null set. Questions on the derivative, questions on the simplification. Quotient rule, derivative of the top times the bottom minus derivative of the bottom times the top over the bottom squared. Distributing 3x squared through here. 6x times x cubed here. Combine 9x to the 4th minus, what did I just say? Combining 6x times x cubed, that's here. 9x to the 4th minus 6x to the 4th is 3x to the 4th. Here I get a GCF. Set the top equal to 0. It's these two equations, but one of them only one of them works. The other one is a non-real answer. The bottom is never 0, right? For the same reason that this x squared plus 1 can't be 0. That one wasn't as bad as I thought it was going to be. All right, so we have about 15 minutes. Look at number 6. Which in number 6 looks the most entertaining to you? They all look fun, don't they? Okay. B or C? What do y'all want? B? C? E?
Which one looks the most difficult to you?
The one that looks the most difficult to me is E. And the reason I say that, I haven't gone through it, is that really, if you look at, A is college algebra. That's a polynomial function. I mean, like we could graph that in college algebra. We just couldn't get all the detail that we can get here. B is a rational function from college algebra. C is a rational function. And D is a polynomial. So those are all things that you've seen in college algebra. E is the only type of function that you really only see in calculus, right? That's the only thing, like E is something that you would never be asked to look at in college algebra.
Yeah, because you got the quadratic rule and then you got the chain rule.
Yeah, that's not a rational function, it's not a polynomial, it's not an exponential function, it's not a logarithm. It's not a line. It's not a parabola. So, I mean, it's all the things that we studied in college algebra. This is not it. So, wouldn't it be nice to show that we've actually come somewhere and we can graph something like that? See, this is where, this is the type of problem I want to put on tests. But when I do, I get, you know, rate my professor that my tests are so hard. And, you know, the problem comes directly out of the book. Do I sound a little, what do you call it? Bitter, yeah. Do I sound bitter?
So do you even look at my professor?
Yeah, sometimes. I do. I mean, not often, because most people go there just to complain, but it's like, but there are a lot of students that do look at Rate My Professor to determine who they want to take, and you know, it's is what it is.
With the other professors?
No, I just look at mine, because if there's ever anything that I don't, you know, I will rebut sometimes. I have rebutted a few things before.
You can get on there and talk back?
Uh-huh.
Yeah.
I have to register myself, and they have to verify my email and everything. Yeah.
Well, that's cool.
Yeah.
Professor Roller, Google, honest feedback.
Yeah.
It's obvious the student didn't develop good study habits.
Yeah. All right, let's see what we can do here. We only have 13 minutes. Domain. We do have a domain problem here, okay? Because we can't take the square root of a negative number, which means we need to make sure that 8 minus x squared is greater than or equal to 0. And this is a quadratic inequality. This is not a quadratic equation. So we have to figure out when that's greater than 0. So now you have to draw back on college algebra. How do we solve quadratic inequalities? Well, we first write it as an equation. And we solve that. And we do get two answers of positive and negative root 8. Then what we do in college algebra is we plot these on a number line. Not doing any calculus yet. And I figure out whether or not this inequality up here is true or false in each of these three regions. So let me pick something over here. Negative, what's a little bit further over? Yeah, negative 3 would work, right? I could be real safe and go negative 100 though, right? I mean, just to really be safe. What happens if I go 8 minus negative 100 squared? What's negative 100 squared? Big, right? But 8 minus that number, it's negative. So that does not work, right? Then a number here, between a negative and a positive, we should always have 0, right? If we plug 0 into this inequality, it's true. That works. And then when I try something over here, it doesn't work, right? So the domain of this function is just the stuff between and including negative root 8 to root 8. So the domain, negative root 8 to root 8. That means when I graph this, I'm not going to have a picture going out both directions, am I? That's good, because I won't have to do a horizontal asymptote. I won't have to do limit as x goes to infinity, will I? Right? All right, symmetry. And who cares? All right, x-intercepts. No, it's not well, no, because our interval is equal on both sides, so we could have symmetry here, but I'm not going to look at it. X-intercepts, let's set this thing equal to 0. The good news, it's already factored, right? So I can set each factor to 0. That's this one to 0. I can set the root equal to 0 and solve both of these. So where do we have answers here? 0? Yeah, square both sides there. And then do your same thing we did a second ago, plus or minus root 8, right? So if I'm graphing this, here's what I know. If I were to graph it, I know at 0 I have an x-intercept. At root 8, I have an x-intercept. And I know that negative root 8, I have an x-intercept, right? Now, what about y-intercept? it's the same as the x-intercept, right? It's 0. So we've got that. Again, I'm running out of time, so let's just keep moving. Horizontal asymptote. No, right? Because the interval I'm on, I cannot go to infinity both ways. See, what happens when I go to infinity? If that goes to infinity, this is 8 minus infinity. That's a huge negative number. Square root of a negative number, not happening. Vertical asymptote. Nope. Don't have any division by 0. All right, derivative time. So let's find our first derivative. Product rule, right? Here's your product. Derivative of the first function is 1 times the second function. Plus derivative of the square root of something is 1 over 2 square roots of whatever's inside, then times the derivative of what was inside the root, chain rule, then times x, which was finishing off the product rule. That's your first derivative. Cleanup time. Root 8 minus x squared minus x squared over root 8 minus x squared. So I canceled the 2's here. The negative came out. X times x squared. Yeah? I have to set that equal to 0, but I also have to take the derivative again, don't I? For the second derivative? You want to do the second derivative now? We could do a common denominator. You want to do a common denominator then derivative? It's really up to you. Sometimes it's easier one way than the other, but I can't just give you like a blanket statement of always do it this way when you see that it's, you know, you just got to go with something. Oh, let me do a common denominator. We'll take a look at that and we'll see if it looks nice. So what do I have to multiply by to get a common denominator here? This one over here, top and bottom by that root thing, right? The root, when I say the root, I'm saying the root of this, right? Yeah. And what happens when I hit the root of 8 minus x squared with the root of 8 minus x squared? Square roots go away. Just get 8 minus x squared. That'll be over the common denominator. And minus this one, which is minus x squared. All of that over common, which is just 8 minus 2x squared over square root 8 minus x squared. That's not so bad. I might want to take the derivative of that one. I think I do want to take derivative of that one. That's going to be a quotient rule. It's going to be ugly, but let's talk quickly about if we had to set this to 0. Top to 0, that'd be okay? Yeah, I think you get what? 2 and negative 2? Yeah. And then you have to say, when is the denominator 0? Well, that's only going to happen plus or minus root 8, right, which are endpoints of my interval. All right, so I have critical points, but they're endpoints, so I can't test on the other side of them, right? Like, look over here. I know if I plug these in, my derivative is undefined, but I can't test to the sides. So whatever I test in here is going to be okay. But I'm going to have some other test points, right? 2 and negative 2. And those are in here. All right. Let's do the second derivative, because I always think that's the hardest part with a problem like this.
And if we want to move it to power rule, it would be just 8 minus 2x squared times 8 minus x squared to the 1/2.
Quantity to the negative 1/2. Yeah. Which you're welcome to do, but I'm going to go with quotient rule. Second derivative is, all right, derivative of the top, what's that? Negative 4x times the bottom, which unfortunately is that root, minus, now the derivative of the bottom is, what's the derivative of the square root of something? 1 over 2 roots of 8 minus x squared times the derivative of what's inside of it, negative 2x, and then that was the derivative of the bottom, right? Times the top, right? Everyone agree? Derivative of the top times the bottom minus the derivative of the bottom times the top. So I've got 8 minus 2x squared. Shit, okay. All over. Well, this is good news, right? This thing squared is 8 minus x squared. It's about the best news we had all day right there with this problem. All right, I'm going to try and clean up. I don't even know how I want to clean this up. Well, I do, but let's see. This is equal to negative 4x root 8 minus x squared. I have a minus and a minus, right, which is going to become plus. So plus, this 2 and this 2 cancel. I have an x up there, and then I have this thing in parentheses up there, don't I? Yeah? So would you like me to leave the x on the outside? Do you want me to move the x in? Do you care? You want to leave it on the outside? So I'm going to have x and then 8 minus 2x squared over that root that was still down below it. But all of this junk on top of 8 minus x squared. Any ideas here? Common denominator. Right here, between the top two. And so what do I need to introduce? Square root of 8 minus x squared on the top, root 8 minus x squared on the bottom. And again, more good news, right? This root, that root go together, roots go away. I'm left with an 8 minus x squared, right? In parentheses, though, this times this. I still have a negative 4x in front of it, don't I? So I'm looking at this. Negative 4x, then the 8 minus x squared, which used to be the root times the root. I'll have a common denominator, so I'm going to say plus x and then 8 minus 2x squared. All over the common, all over 8 minus x squared. Shall we clean that numerator up? I have 1 minute. Clean the numerator. Okay, the numerator, once cleaned up, distributing through negative, 32x, that's this and this, plus 4x squared. I'm going to distribute that x through. Plus 8x. Oh, crap. What should I have done here? I see something better. These both have 8 minus 2x. Oh, wait. Did I forget? No, these aren't the same. I take that back. This one is 8 minus x squared. This one was 8 minus 2x squared. Okay. All right. So top 8x. I'm still good. All right. 8x and then minus 2x cubed. Where? No, because of the 2. I couldn't do that.
The first one doesn't have a 2.
Shoot, man. Wow. Okay, so that's the top, right? Now, check out the bottom. I am out of time, but the bottom, isn't the bottom a fraction like this? And so I can flip it, right? When I flip it, it joins up with the bottom one. And I'll clean that up too in a second because these two go together. But let me try and resolve the top because that looks like a mess. I have,
Combine like terms and factors.
yes, let me see if you follow this. Minus 4x squared. Oh, wait. 4x what?
4x cubed.
Oh, this was cubed.
You should get 2x.
Oh, thank goodness. Okay. I thought I was going to have to do a factoring by grouping. All right. -32 plus 4x cubed. All right, so that will clean up real nice, won't it? We're going to have a 2x cubed minus 24x all over. Now this is 8 minus x squared to the 3/2. And that's because this is 8 minus x squared to the 1/2, right? And this is 8 minus x squared to the 1. And when you put those together, you add the 1/2 and the 1, you get 3/2. And I think at that point you can just, factor out a 2x, be left with x squared minus 12 over this. And so you have critical numbers. They're at 0, root 12, negative root 12. And I believe square root 12 is in our interval? Or did we have an interval?
Yes.
We did, right?
Negative root 8.
Oh, are those in there?
No.
Those aren't in there. Interesting. Okay, we're out of time. You get the idea, right? You get the idea. If these didn't land in our interval, right, then what? Then we don't test them. We have to test on the sides of 0, though, right? But we couldn't go outside of root 8 because of the original interval. Yeah. All right, so yeah, I'll see you on Monday. I guess that's all we're going over, huh, on the test? I don't think there's anything else. It was mostly just chapter 6. Or chapter 4? Sorry, chapter 4.
Not 6.
Right?
That's 2, right?
Yeah. Last exam
Next
and
in mean value theorem,
Yeah.
shapes of graph, curve sketching.
yeah, that's it.